So today we're going to look at a method of determining the amount of vitamin C or ascorbic acid in samples of food and drink. We're going to use a solution called DCPiP in order to do that. DCPiP turns colourless in the presence of vitamin C. It turns red in the presence of other fruit juices. So I'm going to start off by drawing up 1 cubic centimetre of DCPiP into a syringe. I'm going to slide it down the side of a test tube, try not to introduce any excess air into it. So down it goes like so. That's going to be my indicator. And the first thing I need to do is to determine how much pure vitamin C it takes to actually turn DCPiP colourless. And I'm going to put that volume into step 4 in your lab sheet. So I've drawn up 5 cubic centimetres of. I'm going to add these very slowly, drop by drop, into the test tube, and I'm going to determine the amount of vitamin C it takes to actually turn it colourless. So away we go. So I'm dripping the vitamin C in, and I'm filling it in there like that. And you can see that the DCPiP has now gone colourless. I'm just going to see how much vitamin C it actually took, and I can see on the syringe that it took 0.75. So I'm going to write that onto the sheet on step 4. And that's going to give me my baseline figure. I'm going to record it down in step 8 as well. Like so. Now I'm going to repeat the process with some orange juice. It's a specially prepared superated orange juice, which I obtained from a health food shop. I've no idea what the vitamin C content of it is. They said it was wonderful in the shop. So I'm going to start off again by drawing up into a clean test tube 1 cubic centimetre of DCPiP. That's going to be my indicator. There it is. And now what I'm going to do is I'm going to basically draw up some of the orange juice from here, and I'm going to add it drop by drop into the DCPiP, and I'm going to see how much it takes. So I've got a clean syringe here, just draw it up to the 5 like so. I'm just going to get a clean glass rod, and I'm going to pop that into there, and then I'm going to add my DCPiP, my orange juice in, just gently agitating. You might be able to see it's beginning to go slightly red. The important thing is not to rush it. It's going gradually lighter, because once you've overshot the end point, that's too late. And what we're going to do is we're going to compare our analytical results with the claims on the manufacturer's bottle. You can see it's going very light now. We're almost there. So I said you can't rush it, and for goodness sake don't do it as though you're whisking an egg. And what you're looking for is not for the orange juice colour to disappear. You're looking for the DCPiP colour to disappear, and it's almost gone. We're almost back to the orange juice colour. That is almost there, taking into account the dilution effect. Just add a little bit more. And so if we look on our syringe, we can see that we started with 5, we've finished up with 2.8 from 5, that's 2.2. So we've actually used 2.2 cubic centimetres of the juice. Cubic centimetres, I'm going to put units in the top there. Okay, so this is the Y reading. This is superated OJ. Our calculation then is to divide the 0.75 by 2.2, and that will give us our actual amount of vitamin C in that fruit juice. And basically it's not looking too good. It's certainly not up to the manufacturer's claims. What you'll then be doing is turning over the page and looking on the labels of the fruit juices. You will find the content there is spelt out. So for each manufactured fruit juice, just add the vitamin C content per 100 cubic centimetres and convert that into milligrams per cubic centimetre simply by dividing by 100. And then you can say how far the manufacturer's claims are supported by your own investigation. And that's your opportunity to actually comment on what the manufacturers claim.